So, hello everyone, and welcome to a video that I wanted to make for quite a while. So, right here we have a GTX 480, and this 480 is dead. I bought this thing as dead quite a while ago to do exactly what I'm doing today, and it's taken until today to do that because, well, I bought it as broken, and I didn't repair it, but I did something to it that made the card run again for a bit. I'm not gonna give you any more clues as to what I did than this, because I don't want people to actually do this, because people think that's actually a fix to like get their card working again. But no, your card will end up like this. So, this 480 is dead, and I'm gonna turn it into an E-Power today. Now, you can see I already made a mark as to where I'm gonna cut it. I am leaving the memory VRM on the card, and I'm also gonna leave this thing just so that I have like a straight edge on the board. I don't exactly know how to make the memory VRM on this work, but I will try to make it work, which is why I'm leaving it on. If I didn't want the memory VRM to work, I just would have just like cut here. But I think I might be able to get the memory VRM working eventually. So I'm gonna leave it on the board like this, and my plan is to have my connections on the back right here. So if you look, you have these areas where there's a lot of vias, and this is all V-core. Actually, this MOSFET thing is also V-core. So I'm gonna scratch this up and have V-core here, and then here where you can also see a lot of vias, that is ground. So I'm also gonna remove the solder mask here and then have a nice ground hookup. And I believe this part here actually is also ground, and since that's staying on, I could use that as extra ground. And then if that's not enough, I have further on the front here, like that right here is also ground where these vias are. And then in between here, I also have more V-core where I can get in with my drummer with a little, you know, not really drill bit, but like, you know, a bit that can like scratch the solder mask away, like I'm doing with the screwdriver right here, just a lot more efficiently. So yeah, so that's the plan. I'm gonna cut this, I'm gonna set my Dremel up. Cutting PCBs is not healthy. The fiberglass dust that you create while cutting this, you do not want to breathe that in. So I'm gonna be wearing an FFP2 mask. These are easy to come by, thankfully. And I have I have my vacuum cleaner right here. I'm gonna turn that on to hopefully just like suck most of the dust away, so that I don't have a major cleaning disaster once I'm done here. But yeah, I'm gonna turn this 480 into an E-Power today. I'm not entirely sure. Well, this will probably go into a GTX 980. If you remember the 980 where I repaired the power stage, yeah, I broke another power stage on it, and at that point I couldn't be asked anymore. I removed the V-Core VRM on that card, and I'm E-powering it. This will probably end up on that card. But yeah, so I just wanted to document how I make a DIY E-Power for a long time now, and today I've decided to make one. So yeah, here goes. I'm gonna find a way to hook up the camera now while I'm cutting this. So, yeah, so the E-power is cut. You can quite nicely see the layers actually. And yeah, so there's a bit of a problem because my cut was exactly where these multi-layer ceramics are, so I ground them down as much as I could. There's still a little bit there. So let's check if we don't have a short circuit somewhere on the output, because if we do, we're gonna have to grind it a little bit more. So since we don't want our E-power to like blow up once we try to turn it on. So the most important thing is the core VRM. Yeah, that's good. And then the memory. Yeah, that's short. So there's a short circuit somewhere on the output of the memory. It's not too big of an issue right now, because I know by default this doesn't run. Like, I've turned 480s into E-powers before, and I currently do not know the steps on how to make the memory run, so it's not too big of an issue. The important part is that the core VRM doesn't have a short circuit. But I imagine that like one of these multi-layer ceramics is like when multi-layer ceramics get damaged, they usually just short circuit internally. I'm pretty sure one of these is just short circuited and I just need to completely remove them. Or maybe just I need to give the layers another grind. I see like a little bit that's still left around here. But since I'm currently only planning to have this be a one output E-power, I'm not gonna do anything more now. I'm just leaving the memory VRM on this to potentially enable it down the line. So yeah, right now we're fine. So what I'm gonna do now is scratch away at the solder mask to expose the hookup points. Because previously I just removed these capacitors on the front and then used their pads as hookup points. Those are not very good. Those pads are not very big, and also you just remove capacitors from your output. I try not want to keep all the capacitors this thing has at the output, so I'm gonna scratch away at the areas that have like all these vias in them to get connections, and then potentially do the same on the front. But I want to mostly keep it on the back. And yeah, so I'm gonna do that now. So that would be the demasking part. So we have 5 hookups for V-core and then 3 bigger ones for ground. I'm not entirely sure if that's gonna be enough. Like, if I manage to get copper plates onto that, it's probably enough, but if I get forced into using like cables and stuff, then this might be a bit problematic. Now, there is a pretty big like layer back here. That might be ground, since it like extends all the way back. Well, actually, let's check. Yeah, that probably is ground, because those little things, I don't know if you can see it in the reflection, like there's a smaller power plane, and that's where the 16 volt caps have their positive side. So that on the inside there's probably 12 volts, and that around here is probably ground, which should be the same plane as here, like, huh? That might be extra ground, but yeah, like for now this should be enough as hookup points. So yeah, I could pre-tin this, but I don't want to right now. I just want to get this thing working, and yeah, so to do that we need get the mask off now. Where did I put them? Here they are. Yeah, so I bought a bunch of these as well a while back in the anticipation of me building more e-powers. And yeah, so these are LM2596 DC to DC buck converters. And yeah, so these take in 12 volts, which we get from our power plugs right here. Now there's like these pads here, for example. These should be 12 volts for the input side, so we can get them from here. And then we have one that's outputting 5 volts for VCC on the V-core controller right here. So the V-core controller is a CHL 8266. So if we look up the data sheet, if I remember correctly, these right here, this side is where we need to send 5 volts. And then we have a second one, which we're gonna have put out 3.3 volts, and that should be for enable. Now, I think you can send enable somewhere here too, but you can also use one pad for this unpopulated second, base for another. Like, it's a bit weird. Like, you could put another CLJ 8266 here, but the pads from this thing are connected to the pads from that thing. So, like, this might be for debugging or something. Anyway, if you, I think there's like an enable pad here. If you solder to that, it enables this controller. So yeah, I need to recheck where exactly the solder wire needs to go. We're gonna connect that. Could also just use these capacitors for 12 volts probably. Like, whatever's more convenient, because I'm probably gonna put them like this. Now that gets pretty close. I don't know. There's another 12 volt cap right here that we could use, so could put it like this. I'll find something for how to connect that, for how to attach these. So yeah. So that's the thing right now. We need to use these, set one to 5 volts, one to 3.3 volts, and then use them to enable our V-core controller right here. And then as soon as we've done that, we're basically done. Like, when the controller gets power and enable, if we plug in 12 volts into these two plugs right here, our V-core VRM will just fire up. And then we have a working e-power board. Now, we do want voltage control on this, so there's, if I remember that correctly, I think here you can solder your potentiometer for voltage control on this. And then we also have, like, actual voltage control, because otherwise it would just put out the standard voltage, which I think is like 1 volt or something. And then we can attach this, like, using these hookup points to You know, a GPU that we want. And then we have a working e-power board. Only thing missing then would be like maybe some like thermotape some heat sinks onto this VRM so that it doesn't get too hot. And yeah, then the e-power is done. So let's get to the next steps. So it appears that I wasn't completely right. We actually only need one of these, not two, because I took a look at my very first e-power that I ever made. Now this is from a 580, not a 480, which is why those two holes don't exist, but the rest of the card is basically identical. And yeah, so we only need 3.3 volts. We don't actually need a 5 volt, which, you know, 5 volt is right there, so I guess it makes sense. And yeah, so you can see how the buck converter is implemented here. We have 12 volts from the power connector, ground from also the power connector, I presume. It's just, yeah, it's a bit on a cable. So that creates 3.3 volts. And then we have 3.3 volts, one time going to a pad here, which is connected to the enable pin of this controller. And then also going to these two capacitors, which would be the right side of these two, and then also the upper side of that resistor, which we also have right here. So yeah, the hardest part of it is definitely this one, which is why I also plastic dipped it, because hitting that tiny pad while not bridging to any others, this is gonna be quite difficult, and if you rip this off, you might be done for. So yeah, this is gonna be quite difficult. Yeah, but I'm gonna see. Perhaps there is a different place where you can enable this. I'm not entirely sure. I'm gonna do some more research. But if we have to use that pad, then that is definitely the hardest part of this. Though actually, if I remember, I think Lumi made a... Or was it Lumi? I don't know if it was Lumi. No, actually I think it was Miller or MLLR, KLLR 88. I think there's a via somewhere on the front side of this that you can scrape the mask off and then also get enable. I think you can also do that, because the problem is the enable pin from the controller just goes directly into the PCB without anything that you can solder to. So you need to find interesting ways to get to enable. But I think one of these vias on the front here, like you can see all these circular things, I think you can like try to scratch the solder mask off of one of those and then use that as enable as well. So yeah, I'm gonna look up what options we have here and then choose the one that I think is the most, well, best one. And yeah. So I have to make a little insert right here. So what you're seeing right here is the guide on Warp 9 systems that you can find by just looking for, like, just googling GTX 480 zombie power card. That will get you here. And this is a guide by MLLR KLLR 88 on how to make an e-power out of a GTX 480. Now this is the guide that I used for my very first e-power, the one that you just saw. And you see here, you know, that's the hookup points for 3.3 volts around the controller. And here's also that via that I talked about that you can use. You can use these two with the traces on them to orient yourself which one it is, because on the 580 you don't have these holes. Yeah, so I used the solder points on the top for my very first e-power, but then used the enable from this. So this image, I don't exactly remember where I got it from. I wanna say Reddit, but I'm not sure. And you can see, this is where I used my enable, and this is also what I'm gonna be using in the video. And then also, I'm gonna be using this to power the controller in the video, and as you can see, we only need to solder to one component here, whereas this guide says you need to solder to 3. Now both work. All these components are at the end arriving at the same thing, but what this guide recommends is actually redundant, and you're fine just doing this. And this is what I do in the video. So if you're confused as to why I'm only soldering to one thing, because I don't think I mentioned why, this is why. This is also where I got the you know, voltage control point later in the video from. So I'm going off of this guide for the rest of the video, not this one. Both guides work. So you're fine, you can also use this one. You can just find this online, because I don't know where to find the image. Just like, yeah. But yeah, so don't be confused. I'm doing this, not this. Though both is fine. Like, you can choose whatever you want to do. So yeah, let's continue with the video. Yay! Still works. Alright, yeah. And just to check, we are reading a voltage here. And if I go here, I mean, this is supposed to also be only 300. That is a bit... Huh? That's a bit low. Wait, what? Did I just mess with the, Did me reading the feedback voltage mess with the thing? Please don't say me. Please don't tell me I just broke it. No, it works. So if I measure this, yeah, that's correct. So I guess don't measure the feedback voltage with a multimeter. That might break things. Like, the thing is, on this controller, the feedback pin is like basically shorted to VCOR. Like you could see, it's basically the output voltage. So, ooh. Oh, it's the hot plate that's making the sounds. I was already panicking again. Yeah, so like the feedback pin on these things is like basically shorted to the output. So if you just make very slight changes in resistance to that pin, you can very widely impact the output voltage of the VRM. So yeah, I guess don't probe this while it's running. But yeah, so that's the full process of making a GTX 480 V-Core PE power. Like, if I figure out how to make this memory VRM run, I'll make an extra video about it. It's not a priority right now, but I just, you know, left it on there to have it as an option later. But yeah, like, if you have a dead GTX 480 or 580 reference card, like, the process is the same. Like, the layout of things slightly changes, like the 580 doesn't have these holes, and other than that, it should be basically the same. Like, you can do this with a reference GTX 480 or 580. Get yourself a pretty decent 6-phase E-power. Like, this is not gonna power a 780 Ti or anything, but what this will power is like a GTX 680, a GTX 980, older things like a GTX 280, 260, 8800 GT. It will probably also work on an HD 7970, though I don't exactly know if those cards can actually be E-powered just like that. Like, AMD cards are a bit finicky to E-power because they tend to have digital voltage controllers. When these things no longer respond to the driver, which they won't because you will have to remove them for an E-power, the card might not work. At least that's the case on 290Xs and RX 570s. But like older AMD cards, like HD 5000 series, this is gonna power to like a 5870. And, you know, like anything in the sort of 200 to 250 watt range with like maybe a 300 watt peak. It's gonna power that no problem. Now, if you go into like 350 watts plus, this might become a little bit borderline. But yeah, like I have my ePower 5 for that, and you can also turn other cards like GTX 580 Direct CO2s, GTX 580 Lightnings. You can also turn into ePowers. I have turned Direct CO2s into ePowers. I have tried turning a Lightning into one, but I broke the controller on it, and so I didn't. But you can do it. I just, like, if I find a dead Lightning, one day I'll turn it into an ePower too. But, you know, that's the process on how to do it with a 480 and also 580 reference card. And yeah, so like, I finally documented on how to make yourself an ePower. So yeah, you can now make your own, provided you have the exact same board. And yeah, I think I'm gonna like hook up the EVC to this and then do a little check and see if I can actually change the output voltage. And yeah, we're gonna end the video then. So I'll make a little cut right now, and then we'll see what happens. So it seems we're not quite done yet. So if I connect the EVC, it seems to cause a similar problem as when I was measuring the feedback pin with my multimeter. So yeah, what I'm gonna do instead is what I did before and use a trim pod. I might not be able to use the EVC for controlling this. Like the feedback pin on this is, yeah, that usually you have a voltage divider on the feedback pin. On this PCB, it's, you know, there might still be a voltage divider, but it has very, very low resistance if there is one. So I guess connecting the EVC seems to screw with that. Like, it does have the correct voltage for a little bit and then just kind of drops off. So yeah, I'm gonna be using a trim pot to set the output voltage of this, and I guess I'm just gonna be using the EVC for monitoring the voltage. Okay, it is overvolting already. So 1.17 is now the lowest voltage, and if I turn this, hopefully the right way, oh, that's the wrong way, I heard it click. We should be going up as I turn the resistance lower on this. Yeah, oh, not really. The contact doesn't seem to be the best. But it is going up, like 1.2. I just wonder, is that like contact here or contact there? Because if it's contact there, we have a problem. Oh, the power supply turned off again. God damn. Run, you bastard. And now it seems pretty steady. If I play with this, it changes a little bit. Maybe I need to swap this out for like a proper connection later, but like, you know, it is working. So now I'm turning it down again. So yeah, click, click. We can overvolt that way. So yeah, I guess another VRM got pretty hot. Yeah, I mean now it's all putting like 1.25 instead of. I'm gonna thermotape some heat sinks onto this. I don't know if I have any right now. I have some used ones. Like I have stuff like these, which were on like the VRAM of some GPU ones. Like I mean those would fit. But I think I'm gonna get something more proper than that. Just, I need to look for a bit to find something. I mean, it works, right? I could also just see if I have like a GTX 480 base plate, because like this, the screw holes are still on this. I just need to cut a base plate, and then I can like put that onto the VRM as well. That will also work. But yeah, now finally, I don't know how long the video is now. It's probably in the 40-minute range. But yeah, we have a working e-power board now, even though it did take one more step than I thought it wouldn't do. But like, I mean, most people are gonna use trim pots anyway. Like, I just prefer the EVC because it's, you know, more convenient. But yeah, so there you have it, a working GTX 480 e-power board. You can do this yourself now. And yeah, so that would be it. That's it for the video. I'll see about how I hook this up. Like, this isn't the same quality of, like, you know, like a pre-made or like an e-power 5. You have a giant V-core and a giant ground strip. This is not that much, especially for V-core. I might have to resort to cables, maybe copper. You know, like not plates, but like copper wire. Yeah, maybe. But ideally, I'd want copper plates. It's just those are kind of hard to work with, especially when both outputs, like both solder points, are on the back of the board. I'll see how I hook this up. But yeah, like I said before, if things become super bad, I could also scratch the front and get more hookup points there, and yeah, like, you know, that would be it for the video now. And so thank you for watching, hope you enjoyed, and until next time, goodbye.